Hi, so this is a video for anybody that has not been in class the last few days due to just whatever life reasons that you haven't been here. We've been working on the real number system, and as you can see on the attached slide, that the real number system definition is just any number that you can plot on a number line. There are such things as imaginary numbers, but we're not going to really get into that right now, so we'll go ahead and move on. All right, so for the first part of this, these are the definitions of real numbers and some examples. I'll kind of talk through these real quick, and then you should just pause the video so that you can get all the information typed into your slide. So the first set of real numbers you have is natural numbers. These are positive numbers. They start with 1. A lot of times we call them counting numbers. So if you can count it and it's a positive number, then it is considered a natural number. The next set of numbers is whole numbers. There's only one difference between whole numbers and natural numbers. 0 is a whole number. It's not a natural number. I know it's kind of confusing why they would do that and just include one other number, but that's the way that it works. So any natural number is also a whole number, but not all whole numbers are natural numbers, okay? Then our next set of numbers we have is an integer. Now an integer is all of the whole numbers and their opposite values. So, for example, negative 100, negative 5, negative 47. Those are considered integers. Now again, 10 and 15 are also integers, but they're whole numbers too. So, to recap, anything that's a natural number is a whole number and an integer. Not all whole numbers are natural numbers. Not all integers are whole numbers. I hope that makes sense. The last set we have is the set of rational numbers. Now with rational numbers, what we're looking at is any number that can be expressed as a ratio of two integers. Basically a fraction of a over b, and b can't be equal to 0. So as long as you can write it as a fraction with two integers, it's considered a rational number. So if you wanted to put, for example, negative 2 over 3, negative 2 is an integer, 3 is an integer, therefore, that would be a rational number. So, again to recap, all natural numbers are whole numbers, and integers and rational numbers. All whole numbers are integers and rational numbers. All integers are also rational numbers. The last set of numbers you have is irrational numbers. These are numbers that cannot be expressed as a ratio of two integers. Basically, a non-terminating, non-repeating decimal is considered an irrational number. Or a square root of a non-perfect square. I'll talk more about square roots as we move through. But like, for example, the square root of 23, right? And that is what would be considered an irrational number. And then the last one is pi. So let's take a look at some examples, okay? So for this section, what you want to do is you're going to go through and you're going to type out, is this number rational or irrational? I'll look at a couple examples for you to kind of help out here, okay? So let's take a look at this first one, 16 times pi. Well, if we remember from the previous slide, pi is considered an irrational number. It's a non-terminating, non-repeating decimal. So if I take 16 and multiply it by pi, a number that doesn't terminate or repeat, okay, no matter what the value of that is, okay, it's going to be an irrational number. So for that, oops, I'm sorry, I would type in this slide, just double click, and I would type the letter I. Okay. Now this next one we're going to look at is 3/17. Okay, so again we look at 3 and 17. Is 3 an integer? Absolutely it is. It is. Okay. Is 17 an integer? Yes, it is. So because I can express that as a ratio of two integers, I would put an R in the box. Okay. Now I'm going to leave you with a couple more examples. So here. 0.451 repeating, okay? Anytime you have a repeating decimal, okay, that is considered a rational number because rational numbers have repeating decimals. If a decimal number terminates or stops or repeats, it's considered rational. So this would be a rational number. Same thing down here, 0.26. That's a terminating decimal, it stops. So that's also a rational number. A couple of these other ones I want to look at here. The first one is, let's look at, I'm going to jump around, but let's look at the square root of 99. Now, if you think back to what I was saying, the square root of a number is where you take whatever is inside this radical symbol. Is there a number that multiplies by itself to give you 99? Is there an integer that you can multiply by itself to get 99? Well, let me show you a little bit. It's Desmos Calculator, by the way. If you've not favorited that and you're clever, go ahead and do that. So let's say I want to try to find an integer that multiplies to give me 99. Well, for example, let's take a look at this. If I did 9 times 9, I would have an answer of 81. Well, 81 is not 99. And then the next number I can multiply by itself would be 10 times 10. That's 100. So since there's no integer between 9 and 10 that I could multiply by itself to get 99, that would be considered an irrational number. The other way you could do it would be to do this. This button is the square root button on your calculator. You take the square root, type 99. Anytime you evaluate a square root and there's a number after the decimal point, you know it's irrational. Let me say that again. Anytime you take the square root of a number, and if there's numbers or digits after the decimal point, it's an irrational number. So you can just go ahead and move on from there. The next one I want to look at before we go any further, I want to cycle back to this one. This is a square root, meaning one number times itself. This is a cube root because you want to know what number multiplied by itself 3 times would give you the value underneath this radical symbol, okay? So again, there's a way to evaluate that with this calculator that would save a lot of time. This in root, that pops up, as you can see right outside there. You're going to type the number 3 because you're taking a third root. Click the gray box. 125. Square root of 125 is 5. It's 5. 5 times itself 3 times. 5 times 5 times 5 is 125. Well, is 5 rational or irrational? Well, if you remember back, 5 is a counting number. It's a natural number. So if it's a natural number, it's a whole number, it's an integer, therefore it would be a rational number. Okay? What I want you to do real quick is go through and evaluate the rest of these. 128%, square root of 18, 6 to the 4th power, row, 1 squared over 8 and 1/3. Pause the video, put in I's or R's, and then you can come back and I'll have the answers for you. Okay, now that you've paused. So, 128%, you can always convert a percent to a decimal by taking the percent and dividing it by 100. That answer, 1.28. 1.28, that's a terminating decimal. That makes that a rational number. Square root of 18. Again, you can evaluate it one of 2 ways, or you can just use the fact that you know that 4 times 4 is 16 and 5 times 5 is 25. And since 18 falls between 16 and 25, you know it's irrational. Or again, you can always just evaluate the square root of 18. There you go, numbers after the decimal point, irrational. I can evaluate that if I want. If I take 6 and multiply it by itself 4 times, I'm going to get a number that doesn't have any decimals or anything over it. That's going to be rational. This doesn't look like any number you've ever counted before. It's automatically irrational. Same thing here, 1 squared over 8. 1 times 1 is 1. You have 1 over 8. 1 is an integer, 8 is an integer, thus rational number. And then last one, 1 over 3, same thing. 1 is an integer, 3 is an integer, rational number. So go ahead and take another quick pause, and then you can go ahead and correct any mistakes you've made. Move to slide 3. All right, I hope you had a minute to correct any of those mistakes, and now we'll go ahead and work on slide 3. Slide 3, what we're going to do is we're going to put a box, an X in each box that satisfies this. I did a quick copy and paste of that box because for some reason it's been deleted. Anyway, moving back on. So here's what you want to do. The first thing you want to do is figure out if a number is rational or irrational. And then if it's irrational, you're not going to want to put any more x's in any other box. If it's an irrational number, it cannot be rational or an integer or a whole number. It's a separate family. If it's rational, then you have to figure out if it's an integer or a whole number. So let's take a look at the square root of 64. Okay, a couple different ways to do it, but let's just quickly, for the sake of time, square root of 64 is 8. Okay, so 8, that is a rational number. So I'm going to double click the box, I'm going to type R for rational. Is 8 an integer? Yeah, it's a whole number too. So in this case, the square root of 64 is, I'm sorry, I typed the wrong thing. This is why it's important to know that sometimes we all make mistakes. So I should have an x, and then x. All right, 5 over 8. Let's actually, I'm not going to do 5 over 8. I'm going to jump down here and I'm going to do the negative, I'm going to do the square root of 80. So I'm going to do the square root of 80. Evaluate that. Square root of 80 should be, here we have numbers after the decimal point again. So since there's numbers after the decimal point, I know that's irrational. You can just jump down here and type in I. Right. Please take a few minutes on your own and again follow the steps. Okay, is it rational or irrational? And then, is it an integer? Is it a whole number? Go ahead, put your x's in the boxes, even though I'm not doing that, I don't know why. And then we will come back. So go ahead and pause and fill in your x's. All right, so 5 over 8 is just a rational number. 5 is an integer, 8 is an integer. Negative 0.067 is also just a rational number. Okay, it's a terminating decimal. It can only be rational. Integers and whole numbers, they can't have fractions or anything after a decimal, so you can't have that. Okay. Now, negative 17, is it rational? Yes, it is. Is it an integer? Well, that looks like the opposite of the whole number 17, so it is an integer. Is it a whole number? No. If you go back again, whole numbers have to be positive. This is the end of part 1, and then part 2 will be posted for slides 4 and 5. So, see you in a few minutes in part 2.